All right, continuing with our discussion of conics, the next conic section we're going to talk about is the circle. I don't know if I've mentioned it before or not, but a conic section is what's formed. If you picture a three-dimensional cone, I guess all cones would be three-dimensional, but if you picture a cone, let me draw one here real quick. Depending on where you slice that cone, if you cut it straight across, the cross section that you get would be a circle. If you drop the knife in at an angle, you get something more along the lines of a parabola. Or if you cut clean through it at an angle, you get an ellipse. So all these different conic sections, as they're called, that we're talking about, are cross sections of a cone if it's sliced. So a circle is the set of all points on a plane equidistant from a center point. So what that means is if you put a point down, and then you put a nail there and tie a string to it and run the string out a certain ways, and then you put a pencil down, all of the points that that pencil can touch, that's a horrible circle, but you get the idea, all of the points that that circle or that pen can touch would create the circle. It is every single point that is the same distance away from the center. A radius is a segment that has endpoints on the center and on the circle. The radius is the distance from the center to those points. So we talk about those points being equidistant. Well, that distance is the length of the radius. We can write the equation of a circle, and it comes from the distance formula. So let's look here just for a second. We all recognize the distance formula. X minus x squared plus y minus y squared equals the distance. But if we label one of the points h and k, because that's the center, right, that point will never move. So we could label that, let's say that's, I don't know, looks like it might be 2, 1. If we make that 2, 1, the 2 and the 1 are never going to change. But all of these other points might, right? Because it could be any one of those thousands and thousands of points, but they're always going to be compared to this one. So because those other points can change, we leave them as variables. And then h and k can become our center, right? So in our little example here, 2, 1 maybe. If we square both sides to get rid of the square root, we end up with this, the equation of a circle. X minus h squared plus y minus k squared equals r squared. hk is the vertex. Just like with other things, it's backwards, right? So we got minus. So if this is x minus 3 and y minus, let's say y plus 5, then our vertex is at 3, negative 5, because we're subtracting, the signs change. But the hk tells you where the center, I said vertex, that would be the center of our circle. Okay, r squared, r is the radius. Right? It's because we're talking about the distance formula. We're talking about the distance from these points to the center. That's the radius. So that r value is the radius. So r squared is the radius squared. Okay, so this is the standard form of the equation of a circle. The center is at hk and the radius is r. If you need a second to put this in your notes, go ahead and pause the video. I'm just going to keep moving. Appliances and More offers free delivery within 35 miles of the store. The Jacksonville store is 100 miles north and 45 miles east of the corporate office. Write an equation to represent the delivery boundary of the Jacksonville store if the origin of the coordinate system, meaning 0, 0, right, that's all that means, is at the corporate office. So we've got a little 0, 0 here. That's our corporate office. Jacksonville is 100 miles north and 45 miles east. If we converted that into a graph, right, remember it's north, south, east, west. So east would be to the right, 45 miles. 100 miles north would be up here, so let's say it's right there is our center. That's going to be 45, 100 would be the coordinates of that, right? And then we'll go within 35 miles of the store. So we go 35 miles to the right, 35 to the left, 35 north, 45 south, 35 in any direction. And what shape do we start to get? Well, it's going to be a circle, right? So x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. There's the equation that would represent the delivery boundary of the Jacksonville store. That's as far as they will go. So here's another circle. Let's write the equation of this one. This time we're given a graph. So I see that my center is at -3, 1, and then I have 1 point on the edge of the circle. Let's just plug things in. So I have h and k, right? It's x minus h squared plus y minus k squared equals r squared. So I have h and k. So let's say x plus 3 squared plus y minus 1 squared equals r squared. Now I don't know r, but I need it for my equation. I can't leave that a variable. I don't know r, but I do know an x and a y. So if I plug that point in, I can solve for the radius. So 2 plus 3 squared plus y, not y, -1 minus 1 squared equals r squared. I just plugged in 2 for x and -1 for y. It's going to be 5 squared, or 25. That's -2 squared, which is 4, equals r squared. So 29 equals r squared. So the square root of 29 would be r. I don't actually need r, though. R squared is what I want, because I want to put it into my equation. So to finish the equation, x plus 3 quantity squared plus y minus 1 quantity squared is equal to 29. Not 29 squared, because 29 is r squared. And there's the equation of that circle. There's going to be some like that in the homework, I believe. Write the equation of a circle whose diameter has endpoints at 7, 6 and -1, -8. So in this previous example, we had an endpoint and the center, right? Well, now I have 2 endpoints of the diameter, which means I don't have that center point. I have these 2 outside points. A diameter has to run through the center, and the center will be halfway between these points. So if I use the midpoint formula, 7 plus -1 over 2, and 6 plus -8 over 2, the midpoint would be 6 over 2 is 3, and that's -2 over 2, -1. There is the center of my circle, because it's halfway across the diameter. So now I can repeat the exact same process I just did using one of these points, it doesn't matter which one, and the center. So x minus 3 squared plus y plus 1 squared, I'm just plugging in the center points there, equals r squared. I need to find r squared, so I'm going to use 7, 6 to plug in for x and y. 7 minus 3 squared plus 6 plus 1 squared equals r squared. 7 minus 3 is 4. 4 squared is 16. 6 plus 1 is 7. 7 squared is 49 equals r squared. 16 plus 49, that's going to be 55. 65 equals r squared. I don't really need to take the square root because r squared is the number I want anyway. So, final answer, the equation is going to be x minus 3 squared plus y plus 1 squared equals 65. The square root of 65 is the radius of that circle. The circle has a center at 3, -1. So this says to find the center and the radius of the circle with the equation x squared plus y squared equals 100. So remember, we have x minus h plus y minus k, right? Those are both squared, equals r squared. So what number am I subtracting from x? Well, that would have to be x minus 0 squared, right? So the x coordinate has to be at 0. This would have to be y minus 0 squared, because there's nothing there. So the y coordinate is also 0. So my center is at 0, 0. Okay. And then 100 is the radius squared. Take the square root of both sides. 10 is the radius. Now, technically, you're right. It's plus or minus 10, but I can't have a radius that's -10 because that's a length, and that doesn't make any sense. So it has to be positive 10. So the circle would come way out here. And it's going to be hard to draw, but something like this. It could be worse. Okay. Find the center and the radius of the circle with this equation, then graph the circle. I'm going to pause for a second and let you see if you can get a start on this one. So pause the video and then come back either when you get an answer or when you get stuck. But give this one an honest effort before you come back. Okay, I'm hoping some of you got a decent start on this, but if not, that's okay. We'll go through it together here. First thing that you probably want to do is group the terms. So we've got, oops, did my pen, x squared minus 8x plus y squared plus 12y. I'm going to move the 12 to the other side, so equals 12. Okay, now we want to have x plus something squared. I want this, but this is what I have. What you might be remembering is this is kind of the start to a completing the square type situation. I have x squared minus 8x. I need something else there. And I'm going to do the same thing with the y's. I have to add something to these so that they can be factored like this. But if I add it to the left side of the equation, I'm going to have to add it to the right side as well. So I'm going to have two things over there. So cut the negative 8 in half, I get negative 4. Square it, that's 16. I added 16 to the left side of the equation. I have to add 16 to the right side. Then for the y's, half of 12 is 6. 6 squared is 36. I added 36 to the left. We have to add 36 to the right. Now we can factor these. This will factor as x minus 4, and this will factor as y plus 6, y plus 6, which is the whole point. I get x minus 4 squared plus y plus 6 squared. That looks like a circle, an equation of a circle. And then over here, 12 plus 16 is 28, plus 36 is 64. So my center is at 4, negative 6, and the radius is going to be 8. Square root of 64. So we used completing the square to get equations to look like standard form or center form or vertex form or whatever you want to call it of a circle. 4, negative 6 right here. It's got a radius of 8. So we go up to 2. We go out to 12. I don't have room on the left. I don't have room on the bottom, but it would look something like this. Probably. Okay, that's it. I think it's a different homework assignment. As always, feel free to reach out if you have any questions. Good luck with the homework and have a great day.